right, hello everyone. Happy Wednesday. This is potentially going to be your last lesson or the second last. Okay, don't quote me. We have to kind of still decide. But as always, follow along, take notes. Today's lesson is going to be on standard deviation is what it's called. It can be a tricky concept and it can be very time consuming to actually calculate it manually. So you're in luck. We're going to use our calculator today. Please make sure on the top of your paper you put the date, standard deviation, and the notes. We're going to do some quick vocab. I'm going to draw a picture, and then I'm going to give you an example that I think is a nice real-world example that helps explain standard deviation. Okay, so measure of dispersion. When you think about something that's being dispersed, you should think spread out. Okay, if I'm dispersing water bottles to the football team, I would be giving one water bottle per person. I'm spreading them out amongst the people. So dispersion is, when you think of that word, I want you to think spread out, but the math, the way we describe it in math, a measure of dispersion is a measurement that describes the spread of data. Okay, so it's a measurement that describes the spread of data. And what I mean by that, okay, so how spread out is the data that you're looking at? So something that you might think of right away is the range. The range tells you how low to how high the data is. So that would be, I'm going to put a little example box here. Example, range is one way to figure out how spread out data is. And the other way, interquartile range is another one, not as good as the range because the range goes all the way from the max to the min. Interquartile range does tell you the spread of 50% of your data. So range, and I'm going to say, well, let's write it. Interquartile range as well as standard deviation. With range and standard deviation being the best two to tell how spread out your data is. Okay, so what is standard deviation? Standard deviation is the measure of how far a typical value in the data set differs from the mean. Okay, so if you followed that, it really is, so I'm going to write it in the simplest terms I can, as always. So it's the measure of how far a typical value in the data set, so a typical number in your value set, a typical number in the data is away from the mean. Okay, and it can be tricky to understand. I'm going to hopefully explain it down here, but let me draw a picture first just to show you what I mean by the spread of data. So I'm going to write spread here. And let's say when we look at data, oftentimes it's in a bell curve, and what a bell curve is this. So I'm going to draw a skinny one here and a wider one over here. So maybe watch how I draw it first and then draw yours. Leave a little room below so that you can write some info. So I'm going to draw a real skinny one. That's what a bell curve is. And then over here I'm going to draw a wider one like this. Okay, that was really bad. Make yours a little more symmetrical than mine. Okay, we're going to say that this bell curve represents your average test scores with both averages, we'll say two people here. So the mean is in the middle of this bell curve, and the mean is going to be 80 for both people. Their average test score is 80. Okay? So when I look at data that is a bell curve that's thinner, or the data is less spread out, that means like the data is in between here. Okay, so these dots represent different test scores. Some are below 80, some are above, but notice not very far below or not very far above. So this data would be considered less spread out. Okay, over here, this person also has an average score of 80, but they might have a score of like, let's say 70, but then they might have really bombed a test and got a 20 down here, and then maybe they did pretty well and got a 90, and then maybe this was like a great unit for them, so they got a 100. Okay, their scores are kind of all over the place, so we would consider them more spread. Okay, and in the situation back here where the data is less spread, it would have a smaller range, right? Let's say my highest score here was like a 95 and the lowest was a 75. The range would be small. So it would have a smaller range and a smaller standard deviation. And we're going to focus on the standard deviation today. So I'm going to say smaller standard deviation. Over here, since the data is more spread out, it's going to have a larger standard deviation. And that should make sense. Standard deviation is the measure of how far a typical number in the data, so that would be like any point, let's say I picked that one here, is away from the mean. So this one is going to be pretty close, right? This one's going to be pretty close. Like, let's say they're an average of 2 away from the mean, 2 test grades away from the mean. That's a small standard deviation. Over here, let's say they're an average of about 20 points away from the mean. That would be a larger standard deviation, so they would be more spread out. Okay? In a situation like this where it's a smaller standard deviation, we're going to say that the person is more consistent. If they're getting 75s, 80s, 85s, they're more consistent. So even though it's less spread and smaller standard deviation, they are more consistent. Okay, and over here where the person still has the same mean, but they had a 20, and then they had let's say a 60, and then they had an 80, and then a 90 and 100, they are less consistent. Okay, so try to keep track of the difference here with the picture and then the words that go along with it, okay? And now I'm going to give you an example that actually came from a real-world example. I think it was the 2018 draft. I think I got this wrong. Okay, so if those of you might remember, this was 2 or 3 years ago. I can't really remember, but Josh Allen was getting drafted to the Bills. So he was drafted, I don't remember exactly, maybe the 7th pick in the first round. But there was a big debate going on, and it actually happened right when we were teaching this unit in math, about which quarterback the Bills should pick. Should they pick Josh Allen, or should they pick Sam Darnold? And I think there was another quarterback like Josh Rosen or something like that, who was also in the mix. So who should they pick? Who is the better quarterback? And one of the biggest things they were looking at is who is the most consistent. Okay, you want a consistent quarterback when you pick one. And for someone like Josh Allen, we're going to find something interesting about him, and this is true. These are not necessarily fully true, these actual numbers, but what you're going to find here is actually true. So what a lot of people in the draft do is they calculate their average, if it's a quarterback, completion percentage per game, and their standard deviation, because that will tell them how consistent the player is. So we're going to do that for both of these people. Okay, so in order to calculate the standard deviation, you put your data in the same way that we've been doing it this unit, which is in the stat button. So you're going to hit stat, you're going to go to edit, and we're going to do Josh Allen first. We're going to list this is his pass completion percentage per game. So one game he completed 50% of his passes, and another it was 76%, 60, 32. Okay, so just so you know where those numbers are coming from. 50, 76, 60, 32, 62, 36, 52, and 80. Okay, and then in order to calculate the standard deviation, it's the same as before, where you're going to go to Stat, Calc, and hit one variation stat. So hit Enter here. We only have one list, so make sure you don't have anything in your frequency list. Clear it out if you do. Enter, enter. And we have these same data sets here. The standard deviation is this one right here. It looks kind of like the word ox. I say it looks like the O has like a baseball cap on it. That's really not mathematical at all. I'm sure there's a mathematical term that I should be telling you, but we're going to just call it an O with a baseball hat for today. Okay, so that's the standard deviation and it's the population standard deviation that we're going to use. So it's the standard deviation of all the points. So I actually want you to write that down somewhere. Is that it's the O? I'm going to put that in my notes. O X. Okay. So the average or the mean is the X with the line above it, and the standard deviation is this one, the O with the X. Okay. So all you gotta do is calculate or write it down what it says. So his average was 56, and his standard deviation was 16. We're gonna round to the nearest, let's say 100, so 16.03. All right, I'm not gonna talk too much about this until we calculate Sam Darnold. So let's go ahead and do that. So go back into your stat, edit, go up to L1, hit clear, enter, and then let's enter in Sam's percentage per game. 64, 62, 66, 62, 60, 68, 54, and 74. Okay, we can go to stat, calculate, one variation stat, enter, enter, enter. And here we have his mean and his standard deviation. Okay. So his mean is 63.75. That's the X with the line. And his standard deviation is 5.52. Okay. So a lot of people, when they were talking about Josh Allen, they were worried because he had really great games. Like he could throw a game that was 80% pass completion, which is amazing, unheard of. But then he also could throw games with only 32 pass completion percentage per game. Oh my gosh, that's a tongue twister. This is what enticed a lot of people. They said, oh my gosh, he has these amazing games, but he also has these terrible games, meaning he's not consistent. Look at his standard deviation compared to Sam Darnold's, okay? So his average per game, if I'm looking at his bell curve, would be 56. They're saying each data point is about 16 points away from the mean. So 16 points away from 56 would be 40%. But then 16 above that would be, let's see, 56 plus 16 would be, I'm going to do that math, 72. Okay, that's amazing. That's not amazing. So he has these big swings. He's not really consistent. Okay, but this guy, Sam Darnold, he has a little bit of a higher average. So he's already looking kind of better. His standard deviation was 5.52. So he's only 5 away. So his average points are about 5.52 away. So if I subtract 5, that would be about 58. And if I add 5, that'd be about 68. So he's a little bit more consistent, okay? That would be something people would look at when they are going to pick a quarterback. I believe the Bills actually wanted him, but he got picked ahead of time. So we got lucky and we got Josh Allen. So anyways, looking at these statistics, the average and the standard deviation, who is more consistent? Well, more consistent, you want a smaller standard deviation. So Sam Darnold is more consistent. Okay, capital Darnold. How could you argue for Josh Allen, though? So if somebody came into the draft room or whatever and they said they really wanted Josh Allen, how would they argue for him? He doesn't even have a higher average, and he definitely doesn't have more consistency. So why would you argue for him? Because he has really high games. So he's capable of an 80%, capable of an 80% completion in a game. Okay, Sam Darnold never had that. How could you argue for Sam Darnold? Well, you could say he has a higher average. And he's more consistent. So even though he's never had an 80% game, he is around in like the mid 60s almost every game, and you want consistency. All right, so that's how standard deviation can be used in the real world. Remember, higher standard deviation means the data is going to be more spread out. It's going to look like that, right? These numbers jumped a little more. And it's going to be larger standard deviation, less consistent. Smaller standard deviation means the data is less spread and the person is more consistent with a smaller standard deviation. That is it for me today. I want you guys to, on the back, do your follow-up questions. It seems like a lot, but it's really not so bad. It's just a lot of me writing. So if you are writing these down manually, please pause it and copy this down. If you are printing, I will post this on Mrs. Specht and myself's WITS page just to walk you through what we want you to do. So this first scenario talks about George playing basketball, his home games. These are his points per game when he played at home. These are his points per game when he played away. I think this means he's really good either way. I want you calculating the mean and the standard deviation. So you're going to find that in your calculator. So do these first, put all that in L1, calculate, then clear it out, put all this in L1, calculate. And then you can answer these questions. Where does George play better? So I would think a larger mean means he played better. Where is he more consistent? That would be a smaller standard deviation. Okay. Question 2, I want you to pick one here. So a smaller standard deviation means the data is more or less spread. And then 3 is the opposite. Pick one. You can circle one. Oh, I should have wrote pick one. Pick one. And then finally, I want you to name 2 types of statistics or ways of measuring data that would measure dispersion, how spread out data is. Okay, that was from the front of your notes. All right, let us know if you have any questions, and good luck.